I want to talk about doing stoichiometry problems involving gases. And the problem that we're going to look at today is very similar to stoichiometry problems we've done in the past. The only difference is that in the end we're going to convert from moles to something else using the ideal gas law. In this particular case, we're dealing with we're going to be converting to liters. The reaction that we're looking at, if we look at the balanced chemical equation, we always want to start with a balanced chemical equation, is shown here. And so we want to know how many liters of oxygen it's going to take to burn this many grams of C8H18. The path that we're going to take is shown here. We're starting with grams of C8H18 because that's what we're given. We're going to convert that to moles of C8H18. Whenever we want to go from amount of one substance to an amount of another substance, we have to go to moles. The chemical equation tells us about the mole to mole ratio, not the gram to gram ratio. So we're going to go to moles of C8H18. We're going to convert that using the balanced chemical equation to moles of O2. Once we have moles of O2, we're going to use the ideal gas law to go to the volume of O2, because we can rearrange the ideal gas law to solve for volume. Once we know the number of moles from our little path here, we're given the temperature and the pressure, we can find the volume. So if we do that, starting with our 18.4 grams of C8H18, we convert that to moles using the molar mass. We then convert from moles of C8H18 to moles of O2 using information from our balanced chemical equation, which tells us there are 25 moles of O2 for every 2 moles of C8H18. We find that this gives us 2.21 moles of O2. I'm going to take that number and I'm going to plug it into my ideal gas law. So we're going to say the volume, I didn't label it here, but the volume equals 2.21 moles times my ideal gas constant times the temperature, which you notice I converted to Kelvin. 105 Celsius, we need to convert that to Kelvin, divided by 1 atmosphere. And when we solve for that, we find that it's 68 liters.